1 2 3 4 5 6 7 8 9 10 go. This is expert Honda, and we are going to see the lead code question. Okay, so today we have given lead code question is 491, and this is non-decreasing subsequence. Non-decreasing means we don't have to reduce its current value to the next value, right? It should not be that. Like, let's say if I'll talk about, this is non-decreasing order, right? 4. But if we'll take 1 2 4 3, so this should not be a non-decreasing. This is non-decreasing. Okay, it is incrementing order, right? Okay, this was the explanation. Now understand, we have now read the question. Given an array nums we have given, return all the different possible non-decreasing subsequence, and at least 2 elements that should be there. You must return any order. Okay, let's consider this example one in which we have given this one. So first we have given 4 6, then give 4 6 7, then we have given 4 6 7 7, 4 7, 4 7 7, 6 7, 6 7 7 4, and 7 7, right? So these are possibility we have, right? On all the sub array you will see that, so subsequence you say that is coming as what, uh, at least we have 2 element we have, and both are in increasing order we have, right? If that is not increasing, it means it is not decreasing also, right? So if you see, this is the same value we have here, and it is we can say we can put same value, but it should not be in the non-decreasing order, right? It should be not like this. There is a 4 and then it is coming 3. It should always in the what, increasing order, like this, 1 2 3 4 5. Okay, so I think you have understood this question, right? So all the possible non-decreasing subsequences we have to make into an array, and then we have to return that. Now consider about example 2. We have given what? We have given 4 4 3 2 1, correct? So in 4 4 2 there is only one, we have at least 2 we have to write, right, subsequence. So we can consider these two, right? Because if we'll consider any of this number, right, this number or any other, right, so we have to skip this part. Okay, so let's consider one more example. If we have 1 5 2 4 8 5 4 7 9, let's suppose, right? So let's suppose we have this array is given, correct? I'll take like this. Okay, we have this array. I'm going to choose a subsequence. Okay, so if we take subsequence, like from here I have taken 1, from here I'll take 2 in the increasing order, next I'll take this 4, right? Next I will take I can take 8 also, but I'll take this 4. Okay, this 4. So these are we have given. Let's suppose this is our subsequence, right? This is our subsequence, and this is our array. So next element, if I want to add here, right? So we have 7 and 9. So if I'll take 7, right, so we can consider this one as a new subsequence, right? This was the previous subsequence. I have extended now new sequence with the 7, right? So if there is some negative value or some smaller value, right, 4 less than 4, right? If this is less than 4, the next, this is our next value. Okay, next element, you can say next element in array, or that we are considering for the subsequence. So if here x is less than, right, so we have to skip this part. We will not take, like, if there is same we have array, only at this position we have 3, let's suppose, or 2, or let's suppose 1, or let's suppose any other thing we have, right? 0 -1 -8, right? Any of this number we have, right? So we have to skip if this is a position have any of these data, right? So that part we have to skip for new subsequence, right? So only we have to pass that time this we can say subsequence, right? So I think you have understood this one, right? So in this way, right, we don't need we will do a little backtracking, okay, approach, and we'll try to find this solution. Okay, actually, when we are doing the backtracking, right, we do not need any tricks to solve this problem, right? So we have to just figure out like how we can generate all the possible subsequence in increasing order. Okay, and we do not need to go for any standard backtracking algorithm, but we'll do here the backtracking and we'll see how we can develop, right? So if we'll talk about the easiest way, so for the implementation of this program, right, so that is a recursion. Okay, so we will use backtracking function to backtrack to generate all the subsequence, and we'll try to take one function that will take a zero index based array, and we will do we will find increasing order sequences. Okay, so in the, you can say that if the index base index is equal to what nums length, then we have to run out the element, and then the subsequence we have to add at least two, right? So that in see, if there is only one element, right, there is only one element, so we don't need to do anything, right? If index is equal to what, the at the last position, this position, correct, this position, so we don't have to do that also, right? So this will have a base condition when we will reach to this one, right? Okay, so we have to iterate this one. So let's go and do the backtracking. Okay, the Leetcode browser. So what we should do here, we have given this function, that is find subsequence, right? And we have given the array, right, as we have given in the example, correct? So what we have to do, we have to return the list of list, right? So each list contains what, a set of integer, right, that is a subsequence, you can say, and all subsequences we will add onto the list, right? So we have to return that. Okay, so if we'll talk about this find subsequence, right, what we have to do, we have given what nums we have given. Let's suppose, oh sorry, let's suppose uh, we have this subsequence, right, num array we have given, right? So what we should do here, we will find all the subsequences. Okay, so what I'll do here, I'll take this we have to return this one, right? So I'll say this uh, return type is list of list, right? So this list of list is what, our, we can say, uh, you can say result, right, final result we have, right? So we will store somewhere, right, and we'll try to uh, use this. Okay, so what I will do here, I will try to what we should do here, we should use yeah, we'll say we'll take this as a answer. Okay, we'll take this is our answer. Okay, and I will create one array list, new, and we'll say this is our array list. Okay, we have taken what, we have taken this one, and we will return, and we will return this answer. Okay, now we will return this answer. Okay, so what we have to do, we will take uh, the result, right? So we have to store these values here. Okay, so this value is our what, this is our subsequences, right? So this is, I'll say sequence, we have to sequences, right? We will take all each sequences, or single sequence, we can say single sequence we will create, right? So this single sequence we have to take, and each time we will append on the answer, correct? So what we, this is also an array list, and now what we should do, we have to uh, add on to the list, right? So for that, we will I will take some function, and let's say I'm giving my we'll do record we'll do backtrack. Let's say we have backtrack function. Okay, backtrack function related, and this function will take two parameter, right? At least we'll pass the nums that we have given. Next we will take we will start from 0 index, right? So this is our 0 index, and we'll take this single sequence will pass, and another thing we should pass what, our answer. So we will update our answer each time, so we will pass here. Okay, now at the answer this value should be updated each time, so we have to create this backtrack function, right? So let me go here, and we will create this backtrack function, and this backtrack function is not returning anything, so that's why we will take backtrack function void and this function, right? Now what we should do, this is our nums, right? So nums is given what type, integer, and it is array, and this 0 is our index, right? So we'll take int, and this is our index. Next what we have, single sequence we have taken, so this is not about our single sequence, so we have already created this one. We can take from here to here, correct? Yeah, now we have answer. Let's go to create the answer. Yeah, we have defined whatever we have defined our answer. Okay, oh sorry, all the variables that we will use into the backtrack function that we have defined. Now what we should do to use here, okay? Sorry, so we'll take what we should do, we will go to the index, right? We will go to the we'll check first index, if our index is at the last position, right? So we'll take index equal to what, we have given nums and the length. If the last length is equal to at this position, right? So what we should do here, uh, we will stop doing anything, all the things, right? So we have to check if that sequence we have, single sequence will check if we are at the index is at last position, right? So index subsequence dot size should be greater than what, greater than 2, right? So we'll take greater than equal to 2, correct? Now if we have the index greater than equal to 2, then we have what, we have answer, correct? So we will put answer, and then we will add, and we will add what, our this sequence, right? We'll add this sequence onto the answer, right? So each time we will see this answer will get updated, right? And we are returning this answer there, and that's why we are passing into the backtrack, and we'll check like this, and we will update, right? So this is when we are at the last position, index at last element, you can say, right? Means we have checked all the elements till now, and we have make the subsequence, correct? Now what we should do next, we have to check if the sequence remains in increasing order, then we should always append whatever the element we have, right? So we'll say append element, we'll say we have to append the element of nums, right? If it's in increasing order, correct? We should do. So how we'll do that, first we will check if the single sequence we have, right? So if the sequence is what, we will check if this is empty, means whatever will come here, right, at this last index, its value should always be less than or equal to, right? That we saw in the example, we are getting what, 7, right? So or you can say the first example, right, that we will see 7 7, right. So at that time it should be equal. Okay, the previous element is 7, now at this index is 7, so this is less than equal to the value, correct. For remembrance you can take this is subsequence we have given in the example first, right. So in that time we were also considering this is as a new one, right. So either we will check if this is empty, right, if the sequence is empty. Okay, and another is what, its value is less than equal to that value. Okay, this is our current value on the index, and this is our sequence value, that will previous value we can say. So what we should do, we should do size and then minus. So let's suppose subsequence we have what, anything you can take, like let's suppose subsequence we have a value, right. If I'll talk about here, can I append here? Yeah, I should append here. So let's suppose we have what we have given in example 1, we have given nums, right. This is nums, right, and this nums was what, we have given I think 4 6, yeah, 4 6 7 7, yeah, remember 4 6 7 7 was there, correct. So if the sequence is already we have counted like this, and sequence you can say first sequences list, you can say, I'll say sequences list. So first we have taken, let's suppose we have this one, right, 4 4 6 7 7, right. Next time if we have to take this 7, right, so what we should do, we will do the size of this one, right. So the subsequences should come in which way, it is a list of list, right. So I'll take that is our array, right, suppose, but we are calculating from sequence. Okay, but you don't consider the output, don't, because the output was like this. I have to explain so much, so please wait. Okay, let's suppose I'm taking like this. Okay, so next time for I'll take 4 6. First we will take 4 6 as a subsequence will come. Next time it will come 4 6 7, right. So the 4 6 is what, at 6 if we want to check 6 and this 7, right, this 7, so that time we have to check the current, what is the subsequence we have. So subsequence is 4 6 we have, right. Next value if you want to add into that, right, so first we want to check 6, the position, so we will get the 6 from this line of code, right, this line of code, if you understand. So we will get 6. Now 7 is what, at the position of the index, right. So that time like this we are doing. Okay, and so we have appended this one, right. Okay, so next time if we are considering 7 7, so if this is the current position, right, if this is our current position, suppose, so next if we want to append, right, so I'll take a comma and then I'll put this one. So I'll talking about this one. So previous what we have, this one 7, you can say this is previous value, right, previous value in the subsequence, right, sorry, sequence here, subsequence, and this is our current value at the what, at the nums, right, and that's we have to say equal, right, this is equal value. So you have understand equal value as well as less than equal to, right, correct. So if this will match, please ping me if you not understand, I'll explain again. So I think you have understood, right. So, first of all thing we have to check the single sequence is empty. If this is empty, otherwise what we should do, we will use what, single this value, we will check if this is the next value is less than equal to the current value in the sequence, right. If that is the case, we will make another subsequence by appending that, right. If this is less than, let's suppose this was a what, it is 3, suppose it is 3, we will not consider this one, we will not consider this one, this 7, right, this one, sorry, this one, we will not consider this one, and we'll say no, we have to skip this part and we will not clear this one, correct. So let me undo this one. Yeah, not need to undo. Okay, now yeah, previously we were given this one, so we should undo this one. Now consider what we should do next, right? So we have nums, right? So we will append that into subsequence, correct? If this is the value, right? So how we will append this one? So we have given the single sequence, right? So in this single sequence we will add that element. So let's go and add this element. So what we have add the element. So element will get from index, right? Num of index. We got the element. Now we have added that sequence, right? If the element is, you can say, greater than or equal to, correct? Equal to the last element of sequence, correct? If that is the case, now what we should do, we should do backtrack again for the next element, right? So let's go to here. We have already done this one, this job. Okay, so further what we will do, add the 0. What we should do, we should pass this index is already given, we have, will do +1, correct? So we are just incrementing our what, index, correct? Now uh, if we have to do what, if the last element, right, if the last element is not matching, right, if the, then we have to do what, then what we have to do, sequence, if we'll pass, let's suppose, how we'll do that, let's suppose we have single subsequence we have here. So from the single sequence we will do what, now we should do, we should remove what, sequence dot size minus 1, right? So last element we have to remove, right? We have to remove, dot remove, and then size -1, that we are talking about this element, right? This size, we are talking about this size, right? So from the sequence we are getting from there, right? Now we will remove, right? We will remove, we will not considering that element, right? We will delete that element, we will deleting that element from the end of the sequence, correct? Now what we should do now, we should call the what, function again, right? If that is done, let's see if this part is done, then what we should do, we should backtrack again. Nums we will pass, index +1 will pass, and the sequence we will pass, and its result we will pass, correct? All the things we have passed now, correct? Let me check the answer. Okay, index 4 is out of 4. Why? So guys, we have to update our this line of code. Okay, line number 14, we have to return the control if we are at the last index, correct? That we have to do, that we have done here. Okay, now what we should do, we have to update one more thing, the answer, right? This one, this part, because if we are doing what, we are returning the value, right, that we have to update into as a new sequence, right? That is our new sequence. That's why we have to take new array list. Okay, let me run this again. So yeah, our output is correct, coming correct, but it is repeating. You can see this value is repeating multiple times, right? So what we have to do for that, we have to take not array, we have to take set, correct? So we will update into set, and this is our hash set. This is our hash set. So if we are passing the hash set, so this set should be returned into that. Let's me do. Oh yeah, it is saying compatible time is not matching, right? So we have the set and we are returning into the this one, right? So we have to update this one as new and array list, and we'll pass this answer here. Okay, let me submit. So this answer, yeah, one more thing we have to update. If this is set, right, so this is also set, right? Let me try again. Yeah, it's working. So let's understand. Yeah, so actually why we are doing here, each time we have to consider this single, we have to initialize that one, right? And then we have to add into that index, right? So this was previously, it was coming, output was coming null, right? Because we are considering this one as we have the we have the size, right? But we are not doing, we each time we have to consider, if this is greater than equal to, then we will consider as a new sequence, right? And then we will do that. So let me submit this one. Yeah, thank you guys. Please pause this video and try to find the time complexity and a space complexity. Okay, so you will understand the algorithm. Okay, now I'll go to the code section and we'll talk about the complexity. Okay, so see, here we are doing backtracking, correct? We are doing backtracking here, and again in the backtracking we are doing the backtracking, right? Two times we are doing the backtracking. Okay, so it is going to what, n into n times it is going, right? You can consider multiple times, right? But if the length of the uh, array, right, is n, right? So its algorithm is what, we are going to do backtracking from here to here, so it's n square, right? So again in the backtracking we are going to this backtracking, right? And here also we have backtracking, so n, and we are doing two times here n square, and one time one square here, right? So we can say that if we'll do consideration, right? So total time complexity is what we can consider, o o 2 to the power 2 times we are doing n, right? Let me consider here, he will write here. So 1 4 we are passing from the first one to let me write how to write this one too. Okay, so we are, when we are passing from here to this function, right? So we are doing n square, but from here to here what we are doing, again we are passing two times, right? Here to here we are passing two times, right? And so we can say that n square we have, right? Already n square have, so it's 2 to the power n time we are doing 2 to the power n, we can say like this, we will say into n square. Total we are doing like this, right? And if the interval is not satisfied, right? So you can also say we have 2 to the power n time we are doing, right, into what, n, its size. This is the time complexity is taking, right? Actually it depends on the set. If you think about as a set, it will take it is adding the value, right? So total number of subsequences, actually array contains what, 2 to the power n, right? And that is our worst case. But when we are talking about hash set, right, or any other uh, language you are taking, right? So it will take 2 to the power n. Okay, 2 to the power n, that was okay. So and for any load factor that we are inserting or updating, right? So that will take o log 2 to the power n, and that we also consider if we'll talk about the set, so it will consider on. Okay, so if we can say that the complexities remain same, right? But if we'll talk about the space complexity, the space complexity I told you this one, right? This will remain same. This is about time complexity tc, and this is our space complexity. Okay, because space complexity why I'm taking, because see, all the answer will only store into what answer will store all the sequences, right? And that will take what, the length of o of n, correct? And uh, if we'll talk about the storing that part, right? So that is on. So two times we are getting, so we can say uh, 2n, 2 to the power n we are getting to, for the recursion, for the we are doing we are adding, we are doing updating that one, building the stack, you can say, that is it, actually it's making call stack, you can say, right? And that takes our space, right? So a space needed for building the sequence again, and that will take O of n for each recursion, and that's we can say that this will take 2 to the power n into n, right? Or if we take, yeah, we can say that. So thank you guys. Please ping me in the comment box if you like this video, and thank you for some subscribing this channel and promoting through liking and sharing. Thank you so much.